Hello everyone, welcome to GR Lychee 2018 contest webinar. Before we proceed, we would like to congratulate you all for being top 100 contestants for the first phase among 315 abstracts we have received. You all will receive a free board for prototyping your ideas. So you are top 100 winners among 350 contestants. This webinar is to guide you through the GR Lychee design contest and its processes. Emertxe is proud to have partnered with Renesas as a knowledge partner for GR Design Contest in India. We are one of India's pioneer institute as finishing school in the area of embedded systems and IoT. Our core expertise in full stack embedded verticals like microcontrollers, device drivers, IoT protocols and applications, and board support packages. We have contributed to different contests and hackathons in the past. As mentioned, as a knowledge partner with Renesas, our task is to guide in all aspects like evaluating projects, technical guiding, support contestants, and handling technical queries. In 2017, we had supported GR Peach execution, and now again in 2018, we are glad to support GR Lychee Design Contest. The focus is to grow stronger gadget Renesas community among working professionals, engineers, and universities. We thank our co-sponsors for supporting the event, R Limited as award title partner, and Rome Semiconductor as a platinum partner. Now, the agenda for today's webinar is a quick overview of the contest, like highlighting the significance and its benefits, prizes, what you're going to get, board features, what applications can be designed using the board which you're going to get, some development concepts like board setup and tool usages, some demo applications already existing for the board, do's and don'ts, and finally a Q&A session for 15 minutes. A small request to all here, all the questions you get while presentation is on could be typed on the chat window you see in your screen, the response to which would be given once we are into the Q&A session. This is just to make sure we have a smooth presentation. Well, now let's proceed further. To give you a background behind the contest, Renesas is one of the world's leading IC manufacturers. This contest is just to encourage embedded product designers to explore different Renesas platforms in various applications. So the Gadget Renesas community helps to link different ideas with electronics. In this direction, we have a GR Lychee board which will be given to you. It helps you to achieve fast prototyping quickly and effectively. The board is compatible with Arduino Uno. The board comes up with a ready-to-interface camera, Wi-Fi, Bluetooth, and many other interfaces. To have quick and easy development, we have different desktop IDEs and even cloud interfaces. With a brief idea about the contest, let's see what different prizes or awards you may win. The first prize would be 2 lakh rupees, the second would be 1.5 lakh rupees, and the third would be 1 lakh rupees. But please note, all the above cash rewards are subject to tax deductions. We also have introduced different categories of awards. This is just to appreciate all the efforts put in by you. But note, this is only applicable if we have a desired candidate. In the new category we have the first one as BWIN Appreciation Award, which will be going to individuals or enterprises. Means this is for those who bring business with the help of GR Lychee. The next we have a Mentorship Award. This is for those who have an attitude to help others. Generally we call these people as mentors who contributes via social media or our online portals. Here I would like to emphasize one very important thing. We have our website renesasrules.com where there is a lots of activity already happening. So you may go and just have a look there. There is one more which we call it as Contestant Choice Award. This is going to be based on the social media activities. Well, you know, like based on your likes, shares and comments on your projects. and this with the different award categories. Okay, without further ado, let us introduce you to the board. The GR Lychee comes armed with many interfaces, which really helps us in quick prototyping for different set of applications. The first being the brain of the system, the board is equipped with RZA1 series microcontroller. Let us have a quick look at the block diagram. The core is ARM Cortex-A9, which can be clocked up to 400 MHz. The controller has a large capacity on-chip 3 MB RAM. Really, this eliminates the need of external RAM. That's quite impressive. The LCD controller supports graphics buffering up to WXGA resolution. That's really impressive for user interfaces. It has a single CMOS camera too. Coming to interfaces, this controller is quite rich, containing many peripherals like UART, I2Cs, multi-input output SPI, and 3-channel RSPI. These blocks could be used in many general purpose communications. Next, as part of automotive applications, we have CAN, LIN, MLB, and IE bus. As part of audio, we have SPDIF and I2S. We have some other interfaces like smart card, IRDA, MMC, USB, Ethernet, etc. As seen here, it has an analog block of 8-channel 12-bit ADC. It has quite different sets of timers like 16-bit, 32-bit, a watchdog timer, and an RTC. It has an audio functional block supporting 4-channel ASRC. As part of system, it has 16-channel DMAC, interrupt controller, and an on-chip and a JTAG debug unit. With such interesting features built in the controller, let us see what is exposed on GR Lychee board. This board has 2 user buttons as marked at 1. At 2, we can see 4 user LEDs with different colors which can be used as feedbacks or for debugging as you wish. The number 3 is a power LED which is lit up as soon as the board is connected to USB interface. One big advantage of this board is that it is pin compatible with Arduino Uno and ARM embed development platform. This is exposed as GPIO header as shown at 4. The GR Lychee kit contains few connectors which you can solder to add external peripherals. If you have any applications based on motor, you have at 5 a motor control interface. You may connect USB Type-A connector at number 6, which acts as a host if required. At number 7, you have a JTAG interface, and at number 8 is an audio interface, and at 9, a reset switch which is used to reset the board if required. Number 10 is a micro USB. This, when used as USB CDC, the transfer rate of 60 frames per second can be achieved using CMOS camera. At 11, we have 4-pole audio jack. 12, the main USB for embed interface used for programming this board. At 13, we have a Wi-Fi Bluetooth module by ESP. On back side of the board, at 14, we have a SD card slot. 15 is a general purpose LCD expansion connector. At last, we have a camera interface at 16. With all the above features, the GR Lychee board provides us with a variety of applications in various domains. Here are a few examples that can help you decide on the domains that your ideas can influence with strong prototyping capabilities of the device. In automotive application, the Bluetooth and USB access features enhance the advantages of the usages of the device with possible applications that range from audio systems, car infotainment, hands-free calling, rear view monitor display features. The LCD display interface allows for comfort applications in terms of standalone home appliances and smart appliances that are trending in the home automation spheres. The device can be used even in security and surveillance systems with the camera-based applications that can aid facial recognition or video intercom systems and even be interfaced with mobile-based applications with the image data. Imagine if all the critical medical data of patients can be stored on the cloud and given access to any time for all the medical staff. Well, you could do that with these devices. The applications do not stop there. These can also be used in PC peripherals such as UPS and 3D printers. The strong IoT-based prototypes can bring revolution in agricultural sector with smart automatic solutions such as crop analysis, environmental monitoring, and cloud-based solutions with wireless connectivity. If your ideas are more towards traffic management spheres, smart solution for parking, transportations can be realized. Even though these spheres of applications give you a wide net of possibilities, you could think of ideas and domain applications that you think are the need of the day. In the previous section, we had seen some possible use cases that can be done with GR Lychee board. What if we want to implement one? So let's go to some practical aspects by starting with the introduction to IDE. The development for GR Lychee board can be done using two methods. Option 1 is to use desktop IDE. Option 2 is to use web compiler. Let's begin with the desktop IDE first. There are two desktop-based IDEs available. One, sketch-like Arduino style desktop IDE. Two, advanced Renesas GR Studio development environment. We will see the most preferred style by many. In general, the Arduino IDE. But this has to be downloaded first. So let's switch to the desktop. Select your favorite browser. Let me select Edge. Click on it. Visit to the product page of GR Lychee, gadget.renesas.com. Scroll down a bit. Here you see GR Lychee link. Click on it. Now this page, let's click ID for GR link. This is the one. Scroll down a bit. There are multiple versions shown here for Windows and Mac. Let's download the Windows version and the latest one of it. It's a zip file. Need to save it. You may prefer your favorite location. I'm saving it to desktop. This may take some time based on your internet speed. So it's done here. We'll close this. Minimize the browser. So we see the zip file here. Let's unzip it. This again takes good amount of time. Let's keep in the same directory. Navigate to the folder. Run the program id for gr.exe to launch the IDE. The interface looks like a general IDE. The interface looks like a general Arduino IDE with customizations for GR boards. Now, let's concentrate on this part. You have a menu bar on the top, some important function icons, and basic sketch template with an empty setup and loop functions. Let's quickly see some important functions which could be helpful while project creation. Firstly, you would like to store the files in specific directories. By default, it stores in your document Arduino directory. You may use File Preferences to modify the default path. In the same window, you may see some functions like changing the font size, display the line numbers, etc. You may modify them as required. Under the same file examples, you get some nice default pre-written example sketches to do quick start. In this session, let us use a basic sketch just to see how do we use this IDE. So let's select File, Examples, 01 Basic, and let's select Blink. And a new window opens. You may close the other windows. Let's maximize this a bit. Now, before proceeding to the compilation step, we have to select the required target, which you will find in Tools, Board, GR Lychee. Oh, it's already the default. But note that if you plan to work on OpenCV related projects, then you may have to select GR Lychee OpenCV. Well, that's it. Press on the verify icon below the file tab to complete the sketch. To compile the sketch, sorry. This might take some time based on code size. In order to upload the code, we need to interface the board. So let's take the GR Lychee board. Now make sure you connect the USB cable with this embed port. This is the embed port. And first let me connect this. And the other part should go to the system. I have only one port in my laptop, that's why I'm going to use an extension. So first let me connect the extension, and then I would like to connect this to this. So this is the board. As soon as you power up, it just lights. Now press the upload icon. Once upload is done, the target is remounted and you may get a pop-up window which you can close. Press the reset button here. This is the reset button you have. And you should see an orange LED blinking at the rate of 1 second. In case you're working in projects with serial ports, the IDE provides you a serial port option under Tools, Serial Port. You may select the required communication interface. That's it. Other than the desktop IDE, we have a web-based IDE, the Renesas web compiler. The web compiler provides all necessary features to build and complete projects for GR Lychee board. Open the web browser and type gadgetsrenesas.com. As you see here, there are 3 buttons: login, guest login, and register. Be careful, if you log in as guest, the work you have done would be lost, so it is expected you have already registered. Now click on the login button. This will take us to login page. If you are a new user, you can register an account by clicking on Register Now button. Follow the 5 simple steps mentioned above the button to get yourself registered. I am skipping this for now as I have already registered. Now let's log in with the registered email ID. Let me enter my username and my password. Okay, there's a pop-up here. Let's click on retry, and we have a web compiler or web ID here. Since it's the first time login, we are prompted with a project creation window. Type Lychee in the filter. Here you can see 4 options. The good thing about the web compiler is it supports both embed and sketch style programming. Option 1 is GR Lychee embed style OpenCV. Choose this if your project requires OpenCV graphics library. This one uses embed style. Option 2 is GR Lychee embed style normal. Choose this if you want to use an embed style template without OpenCV library. Option 3, we have GR Lychee OpenCV. Choose this if your project requires OpenCV library with Arduino Sketch programming style. Option 4, we have GR Lychee Sketch normal, and this one if you want a simple Arduino Sketch template without OpenCV. So before we get into the project creation, let us explore the features of the web IDE by cancelling this window. On the top left side, we have an Explorer tab with a simple file search icon, a detailed file search option throughout the workspace, and a window control icon which helps us to hide and show the Explorer. A nice feature, isn't it? On bottom, we have a project pane with an import project icon, add project icon, and a minimize icon. On the right side of the IDE, we have file related options. On the top again, you have an icon to hide. Use the save icon to save open file, and save all to save all the open files. As part of the editor feature, we have search in the file and replace icon which helps us to replace text. We can import libraries to include them in the current project with the help of import icon. The execute build icon to compile the project. IDE settings can be changed to change the font size, indent control, and many features. Use split icon to view multiple files if required. And that's it on a quick intro to web compiler. Well, that we know about the IDE and how to use it, let's proceed with some demo of sample codes for the available interface. To start with, let's pick the simplest interface, the LED. So let's maximize the web browser. Click on Add Project icon. The project template window should appear. Enter Lychee in the filter box. As mentioned in the overview of ID, we have two methods. Let's pick the most popular style, the Arduino sketch. So we will select GR Lychee sketch, click create project. Oops, oh yeah, missed to give the project name. Let's give some name, something like LEDs, and it should be done. Right, now let's double click on GR Sketch CPP on the Explorer tab to view it. Well, if you have a little experience on Arduino programming, you would know the typical code structure with two major functions, setup and the loop. You would put all those one-time initialization code in the setup function and all those which has to run forever in the loop function. Now let's see what the application has to do. To start with, we are initializing the serial port with a baud rate of 9600. This would always be helpful while debugging. There are 4 user LEDs on board, so initializing the pins on which it is connected as outputs. The board has 2 user buttons, so initializing the pin on which it is connected as input. All this direction control are done with the help of pin mode function. So this is what about the initialization part. The application is just to toggle the LEDs with a pattern, and if a switch is pressed, it will print I am Lychee on the serial terminal. Let's click on the execute build link on the right side of the ID to build the project. Similar to Arduino ID, this too would take some time to build. The build summary has popped up. You can scroll the window to see the build result. Okay, let's close it. The result of the build would be a .bin file which can be found at Explore tab. Right click on the .bin file and select download. It would prompt to save the selected bin file. Save the file on the mounted partition, which is embed. Now let's click save. This may take a while to validate. On completion of the write, the storage gets remounted like this. Now the download is complete. Let's run our LED sample code. So let's press the reset button. Here it is. You can see the LED pattern program running. That was pretty easy, I guess. It's a matter of trying out and getting used to it. As a next demo, let's see how we are going to look at how you can get started with video capture and image processing on GR Lychee using OpenCV. This demo should give you an idea on how to start working on these interfaces. The good news is it becomes very easy to start with when we have a working source code. The GR compiler interfaces have ample of demo code which can be explored. So let's close this and add a new project by clicking on plus icon in the project tab. Type Lychee on the filter tab. Oh, it's already there. Then we'll select it and select GR Lychee Sketch OpenCV. Let's give the project name as camera and create a new project. Once the project gets created and loaded, it should be seen on the Explorer panel. Double click on grlychee.cpp to view it. As we generally see in Arduino sketches, we have a setup function which calls camera begin, which initializes the camera setup, and a loop function containing main application. The default demo applications demonstrates the use of canny edge detection, which is a most popular edge detection algorithm. The OpenCV library provides an implementation of canny edge detection algorithm. It is a multi-stage algorithm in which the image goes through each stage, starting with noise reduction, followed by finding intensity gradient of image, and then non-maximum suppression followed by hysteresis thresholding, and the final output. See how the image gets transformed into edges. The algorithm is quite complex, but OpenCV puts everything in a single function named canny. We will see how to use it. First argument is our input image called SRC, that is source. The image should be in an 8-bit grayscale format. As you see on line number 26, we are capturing the image from the camera using camera get image address. In this case, we are specifying the image size as 320 cross 240 pixels, which is stored in a matrix called as image raw. The image is in YUV format, which is converted into grayscale format using a function CVT color. The grayscale image is stored in src variable, which is again passed into canny function. The function returns etched in destiny variable, which is also the same type and the size of the source. The third and fourth arguments are the thresholds for the hysteresis procedure. In summary, the canny function finds the edges from the source image and returns the edge map. The destination can be used for further analysis. In this application, we are streaming the edges to a desktop application to visualize the output. To achieve this, we convert the image as JPEG using create JPEG function and then send the image over USB. To facilitate this, we use send JPEG function from the display app library, which sends the image over USB to serial interface. Let's build the project by clicking on execute build. This might take a couple of seconds to build. You may scroll down to see the successful build result if required. Let's close it now. So before we download, let's interface the camera module to the board. The GR Lychee box contains a camera module and a ribbon cable. So these are these two things. First, let's remove the board from the host so that it's powered off. Now, let's connect the ribbon cable first to the board. So this is the ribbon cable you have. So this is the camera connector you have. Make sure the metal part goes upwards, just like this. Before that, you might have to pull this down. Put it, and you have to be careful. Just push it in, just like this. Then let's take the other part, the camera. Keep the board downwards like this. There's a flap here, open it. Put the ribbon cable like this now. The metal part should go downwards now. Just put it in. Pull the flap downwards. That's it. It's connected now. Now to run this application, you will have to connect the GR Lychee board with USB cable at embed port. This, you know it. So first let's connect it. There's a previous output what we have. Then we need one more USB cable which is going to go to the USB 0 port. So I'd like to connect it here. And then this to the PC. Now this is going to be helpful for us to stream the data, whatever comes from the camera, to the host system. The streaming application for the host can be found at the product page of GR Lychee. Click on the new tab icon, type get it Renesas, scroll down. At the document, click on the sketch reference link. In this page, click on Sketch on Web Compiler. Click at 3 Let's Play with Camera. Scroll down. Click at Display App. In this page, click Display App for Windows. Click Save As. Select Desktop and save. Close all these tabs. Minimize the browser. There it is. Extract it on the desktop. Get inside the folder. Click on the display app exe. You're ready now. Let's download the code to the target. Right click on the bin file, select download, save it to the embed partition. It takes some time to download. Once the download is done, the target will be remounted. Now let's switch to the display app window. Press reset. You should see a new communication interface. Click on it. You can see the output now. You can see I'm just focusing my camera to the setup what I have here. So you can see this is my GR Lychee board, this is my laptop, and it's the entry to my cabinet. And you can see my hand coming in between. 1, 2, 3, 4. That's it. Well, I hope you got a good idea on how to use a camera with GR Lychee. Next, let's move on to the LCD demo. Let's close this tab. Click on New tab. Type gadgetrenesas.com. Scroll down. Click on GR Lychee reference at document section. On this page, click on Sketch on Web Compiler link. In this page, let's click on 6 Let's Display on LCD. Scroll down. Click on Display Sample Code. Scroll down a bit. Now copy the code. Let's move back to the web compiler. Click on a project icon. Type Lychee. Select GR Lychee sketch. Let's give the project name as LCD and create a project. Double click on grsketch.cpp. Select this code and replace with the copied code. As usual, the setup function is seen here. The user button mode is set as input and initializing and starting the camera. Starting the LCD with 3 arguments like get image address, getting the width and the height of the camera capture. To start with, let's clear the LCD screen. The loop function just reads the user button state and toggles the LCD state as on or off. If the state is on, the camera capture would be shown on the screen, else it would turn off the screen. This line is just to get blocked unless the user releases the button. As usual, let's build the project by clicking on Execute Build. As mentioned here, this might take a couple of seconds to build. Done. Let's close this window. As a result, it generates a lychee sketch.bin which should be downloaded to the target. So before we download, let's interface the camera module to the board, which is already done. But one thing I would like to do is put the top on the camera because we have a light which is brighter just above. Now we need to connect the LCD to the board. So this is the LCD we have. So to do that, I would like to remove the power. So the LCD connector is just behind the board. So this is the one. We need to connect this to this FPC connector. First you have to insert it like this. Just be careful and you just have to push this flap down. That's it. And let's keep the board like this so that it's easy for us to work on. So done with connections. Let's download the code to the target. Right click on the bin file and select download. It would prompt to save the selected bin file. Save the file in embed partition. and wait for a while. Since the file size is large in MBs, the download may take a couple of seconds. Once done, the board would remount and a notification would pop up, which you may close. Let me press the reset. I'd like to lift the camera and open the lid. You should see my setup there in front, and this is my GR Lychee board. That's it. Well, we have seen 3 demos based on Arduino Lite programming style. Let's see one based on ARM embed. Let's close all the unwanted windows first. Click on the new tab icon. Type gadgetrenesas.com. This will lead to the main page. Scroll down to find GR Lychee. Click on GR Lychee. This will take you to the GR Lychee page. Scroll down to find the technical support and click on the first link. So we have landed in the main page of Embed GR Lychee. Click on the compiler icon and wait for Embed page to load. Here we are. Now make sure you have already registered. Else go to the sign up page and get registered. I have already done, so let's type the username and the password and wait till the page is loaded. Now this is the main page of ARM Embed. Let's create a new workspace by clicking create a new one link. The default is a blinky example. Let's click and change it to Wi-Fi here. Let me tell you all, we will just go through the board bring up like compiling and flashing the code with this example, since explaining all the files and folders here would be requiring a significant amount of time. We are sure you will be able to understand the code if required. Well, don't forget our Gadget Renesas community, which would surely help you in case of any issues. So let's proceed further. The main.cpp file is here. Let's click on it. Here is embed JSON file, which we have to modify to test this sample code. Not much. First, let's give the SSID and then our password here. That's it. Let's save and close the file. It's a simple code which enables a Wi-Fi module and get connected with arm.com and print some network information. That's all. Since we have modified our network credentials, we will have to compile and run this application. Press here to compile. This takes some time. Once done, we get a pop-up to save the file, just the same way we do while uploading using Arduino method. Here it is. Let's save the file in embed partition as usual. The board gets remounted. Let's close this pop-up. The output has to be streamed in serial application. I have installed Termite. Let's search here. Click on it. Here it is. Let's change the COM parameters like baud. Click settings. Select baud. Select 9600 and we are set. Now let's reset the board. Here it is, scanning for Wi-Fi networks. Look, got few networks. Ours is the first one. Yes, it succeeds and prints all the informations. That's it. Hope you got a rough idea on how to work on Embed platform. Fine. Up to now we have seen some demos on how to use the board. What if we need to interface a battery? Well, it requires that you have a clean understanding of the requirements to achieve the required backup. It's better to list down all the required peripherals by your application and its active time to calculate the backup. More number of peripherals, less the backup you're going to get. So just to make it simple, let's take a use case of an agricultural automation with two different requirements. Let's say one with one relay and the other with three relays to start a pump. And let's say we need to run these systems for an hour with a battery of 1 ampere per hour. Generally, a battery life is calculated as battery life is equal to battery capacity by current drawn. Now, assuming a single pin of a microcontroller taking 2 milliamps and a relay takes 50 milliamps, then for a single relay, it ends up with an approximate backup of 20 hours. And the same for three relays, it ends up with a backup of 6.5 hours. Do you see the difference? So as part of interfacing battery to GR Lychee, the easiest way would be using an external power bank at USB 0 or embedded interface. You may directly connect it there. In other case, you may use three AAA cells making up to 4.5 volt and interface. But remember, this requires a good plan. If you're not sure about the power consumption on your board, you may use multimeter to measure. Well, as a summary, be careful while designing power circuits. If not rightly done, you may end up with erratic behaviors and even you may end up destroying your boards. As a last part, there are few precautions that you may take while handling and programming the boards. Firstly, wear static bands if you have. Avoid touching the components on the board with bare hands. Possibly hold the corners. Keep the board in a comfortable place with neat cabling. Avoid liquid sources like water, tea, coffee. Avoid keeping the board on the metal surface. Make sure there are no floating wires in the vicinity of the board. And yeah, possibly switch off the board when it is not used. It's always better. Regarding connecting external interfaces, the connectors on the board are a bit fragile. Be careful while inserting cables into it. You can't be harsh on it. It might break. Verify the directions of the cable while inserting on the board. Wrong polarity might destroy the board and the device. Take precautions while interfacing peripherals to the GPIO. Check the pinout, especially the power pins. The board works on 3.3 volt. Higher voltages are not recommended. If done, you end up damaging the pins. Please don't remove the power while programming. It may end up with a corrupt write. Maybe it's going to seize the target. And please note, we will not be in a position to provide spare boards as per our contest rules. So please handle your board carefully and please follow do's and don'ts specially related to power. Well, until now we had a brief introduction on GR Lychee and its features, and we had seen some quick introduction on how to use an IDE and some sample programs. We will share all the artifacts including the links to the IDEs, documents, source codes which is used in this webinar. And now we are open for the question and answer session. Well, let me pass it to the moderator.
Thank you, Adil, for giving a very nice presentation on the GR Lychee board and the IDE as well as the demo. So with this, we open up for Q&A. So please understand, you will not be able to talk using your mic for the question and answer session. We request you to post your queries using the chat window option available in the webinar software. So please post your questions in the chat window. So we have with us Shweta and Okamiya joining from Renesas. So please post your queries. We'll be happy to answer your questions. We already have few questions received. We'll first answer them. Meanwhile, you can post your queries in the chat window. first question is how to retrieve the image stored in memory, like SD card, for image processing. All right. So many of the applications require a good amount of storage space. So GR Lychee comes up with an option to insert an SD card or MMC card. If you look at the back side of the board, you can see there is an SD card slot available. We can insert an SD card which is formatted using FAT32. And if you want to store and retrieve the files into the SD card, you can use the SD card library available for Arduino. So there are multiple SD libraries available. You can use the SD USB Connect library available for accessing the storage device. So once you mount the storage device, you can use the file operations functions like fopen, fread, fwrite to access the SD card. So if you want to retrieve an image which is stored in JPEG format, so you can use the JPEG library available to specify the format in which you want to read, and you can use the fread function to read the data in JPEG format. So it's so more about this is already available in the GR Lychee product page. So we can refer the documentation and the sample code available in GR Lychee product page. We will be sharing the link to you. I hope I answered your question. The next question says, if we plan to use E2 Studio, is it free? All right, so this question I would like to hand over to Mr. Okamiya. So I would suggest him to answer this question or provide details. Okamiya, I think you have muted yourself. Can you unmute and provide some details about E2 Studio? You can talk now. You are unmuted.
Can you hear me?
Yeah. The question is, if you plan to use E2 Studio, is it free? So can you provide some details about?
Yeah, of course, it is free. Yes, it's free, and we prepared a project for E2 Studio, so you may use E2 Studio for free. Okay. Okay, is it clear? E2 Studio is free, based on Eclipse, so it's free. But the compiler, GNU compiler collection is of course free, but for example, ARM compiler collection for RG processor, it's not free, but E2 Studio itself is the framework for development environment, so it is free, and GNU compiler is free, and GNU compiler for GR Lychee is available, so you can use and develop program in free. Okay.
Okay. All right. So we have thanks Okamiya for answering the question. So we have the next question. What kind of documentation is expected for final project submission? So I would request Shweta to answer this.
Hi, Mubin. Thanks for the question. So we have listed the documents required, or what we consider as a full project submission in the contest rules on website, but I would like to reiterate. So your project or your abstract is selected based on what idea you submitted. So your final project has to be aligned with the idea that you submitted. We understand it, there could be about 20-30% variation depending on the practical scenarios, so that is okay. But say for example you presented idea on agricultural project and you submitted something on smart homes, and which is like totally different, then we will not accept that as the final project, because on the basis of the idea you got selected in top 100. Now in project submission, we expect you to submit a detailed project report, which includes your objective, the working of your project, schematic level block diagram, system level block diagram. If there is a flow chart involved, you can submit that. If you are you're working through a company and there is issue of sharing source code, we request you to don't worry about such things, because we take care of the privacy of the contestants, and as per the contest rules, it's not going to go anywhere else. So if you are hesitant about something, you can submit limited code, and if you are selected in top 20, we will get back to you if we require some more details. Last but not the least, the most important part is the video. So all the selection or all the first level of evaluation is going to happen online, and as a proof of your complete development, you need to work on a video, say about 2 to 5 minutes video of how your project is working, and upload the video or the YouTube link in the submission window. So please make a nice video, don't wait till last minute. So try to finish your project little early so that you have enough time to go and modify if necessary. And as you might have seen in the prizes, we will be uploading those 20 winners video on social media channels, and you have to promote your videos so that you get maximum likes and shares as a very popular project or a very innovative project. So based on that, we will be scoring you for that particular price category. So everything is there on website. If you have any questions, you can just email it to us.
Thanks, Shweta, for answering the question. So we have another question for businesses. For Business Win Award, how to apply? I would request Shweta to answer this question.
Yes, we introduced this category of award to encourage use of RZ microcontrollers for businesses through this contest. If you are a small design house or a manufacturer and you plan to use our platform for your actual commercial application, you please get in touch with us through email, and we will connect you to our salesperson, and we will handhold your development till the final stage. And if it's a real business win case, you get this category, you can apply for this award. So please get in touch with me for further details. Thanks, Mubin.
No, thanks. So the next question is, from where can we get LCD? So I guess many of the projects require LCD to be interfaced. So request Adil to answer this question. I think we have to unmute yourself, Adil. Yeah. Yes, you can talk.
Okay. Yeah, Mubin. It's a pretty standard LCD. It's a 40-pin LCD. And there are so many online vendors like Element 14, and DigiKey, all the things. But one thing is you have to make out that the 40 pins are matching. Make sure it's pin compatible. Okay. Regarding where we exactly get it, okay, you may just send us a mail. You would like to give you the link.
Okay.
I hope, yeah. Just make sure the pinout is compatible.
All right. Okay. So I think you will get LCDs in the market, different types of LCDs. So it's important to make sure that it is pin compatible with GR Lychee.
Yeah. And the interfacing, anyhow, it's in the video also. We have some Renesas web pages. You may go there and you can have the pinouts. Even the schematic has the pinouts. You just refer that.
Okay. The next question is, I want to use a USB camera. Could you please provide details for configuration and programming? So, Okamiya, can you answer this?
I'm sorry, but I'm not sure about that. But RZ microprocessor is not available for USB video class, so I'm not I'm not sure about now, but maybe it cannot be used. But I will confirm and I describe in rules forum. Is that okay?
Okay. I think you can send an email regarding these questions. We'll definitely help you to resolve the configuration related problem. So we have another question. So the question says that is Arduino sensors compatible with GR Lychee board? That is the next question. So Adil, can you answer this?
Yeah, yes, Mubin. See, you may connect any sensors. It's not just like Arduino sensors, but one only thing you have to keep in mind is the GPIO pin should not exceed, the voltage what comes to the GPIO pin should not exceed 3.3 volt. That's one point you have to keep in mind, as well as the device what you're going to connect has to be running in 5 volt, or if you are having any other voltage, make sure you use maybe a voltage divider, or you have voltage translators, but it should be possible to connect.
Okay. Thanks for answering the question. So I think we have plenty of questions popping up in the chat window. Let me pick the last question for the day because the session is about to end. All right, there are many questions. So I'll pick this question. So there was a question which says, how could I configure Wi-Fi and Bluetooth to send data to PC? All right. So Okamiya, can you answer this?
Just a moment. Data to PC. PC. There is an example for a web server with Wi-Fi. It can send a data to PC. So I think there is no problem with the Wi-Fi. Okay, and about the BLE, we are discussing in rules forum, and my iPhone it is able to send data to from GR Lychee to iPhone, but I'm not sure to a PC, because most of PC is I'm not sure the how to send Bluetooth low energy data. I think Bluetooth is available, but Bluetooth low energy, I'm not sure about that. Okay. So I confirm. Okay, I will confirm about the BLE.
Thanks, Okamiya. I think as Okamiya mentioned, we have sample codes available for Wi-Fi and BLE available in the website. But
Yes.
many of time, what it happens is that on the PC, you may not have the BLE stack available. You may have an older version of the Bluetooth stack. So we can look into it and definitely get back to you in the Renesas rules forum for this.
Okay.
So hope we answered few of your questions. So if your questions is unanswered, please post it in the Renesas rules forum or send us an email. We're sorry we could not take more questions as the session is about to end. So in case you face some difficulty in listening to the session, we have a recording of this session uploaded to YouTube. We will share the link to you as early as possible. Feel free to share it with your team members if they are not available today. So you can refer the recorded session for getting an idea about the hardware connections, to learn how to use the IDE and refer the sample code. In case you find any difficulties, do drop us an email. We'll be happy to answer your queries. So just to remind you, the last day to submit the project is 15th October. It's approximately 3 months to go. There is ample time to complete your project. We expect you to submit the project before the deadline. And often we've seen people rushing at the last moment on the last day to submit the project. So please avoid last minute submissions. You can submit at least a week before the deadline. And in case you have any further corrections, you can always update the project documents and the artifacts with your corrections. Thank you all for attending this webinar. We wish you all the best for your project development. Enjoy your development with GR Lychee. Thank you.
Thank you.
Thank you.
Thank you.